Welcome students. Today's question what we have is from the linear differential equation. Using Laplace transform we need to solve this. So question is solve y double dash minus 3y is equal to sine t where some conditions are given. Y of 0 is equal to 0, that is equal to y dash of 0. So let's go ahead and solve this. First let's take the differential equation y double dash minus 3y is equal to sine of t. Since we know that this is the function with respect to t, so we can write this as y double dash of t minus 3y of t, and this is equal to sine t. So now we need to apply Laplace transform on both sides. So Laplace transform of y double dash of t minus 3y of t is equal to Laplace transform of sine t. So let's expand this. Laplace transform of y double dash t minus 3 is constant. Laplace transform of y of t is equal to Laplace of sine t. So we should know some formulas, some basic ideas where we can substitute for Laplace of y double dash of t. So I'm writing here Laplace of y double dash of t can be written as s square Laplace of y of t minus s into y of 0 minus y dash of 0. The entire equation I will be substituting here. This implies s square Laplace of y of t minus s y of 0 minus y dash of 0 minus 3 Laplace of y of t is equal to Laplace of sine t. This implies, see, some conditions are given in the question. So given y of 0 is equal to 0 and y dash of 0 that is also equal to 0. So call this as equation number 1. Now 1 implies, substitute this condition in equation number 1. We will get a square L of y of t minus s as it is, y of 0 is 0 minus y dash of 0 is 0 minus 3 Laplace of y of t is equal to Laplace of sine t. If we see this, we have Laplace of y of t as common term. Take that as common. This implies a square minus 3 of Laplace of y of t is equal to Laplace of sine t minus 3a plus b into s square plus b. I can see that a square I can take common, so that I'll get a plus b of s square minus 3a plus b is equal to 1. Now this also can be written as a plus b s square b minus 3a. So now I have 1 on the LHS. What we can do is we can compare the coefficients on LHS and RHS. This LHS part I can write it as 0 s square plus 1 is equal to a plus b s square plus b minus 3a into 1. If we compare LHS and RHS coefficients, this implies a plus b will be equal to 0. And one more equation we will get, b minus 3a is equal to 1. From this equation, from a plus b is equal to 0, we can write it as a is equal to minus b. Now equation 2, we will substitute a is equal to minus b in equation 2. Therefore 2 implies b minus 3a is equal to 1, b minus 3 of minus b is equal to 1. So I have b plus 3b is equal to 1. 4b is equal to 1. b is equal to 1 by 4. Okay, since a is equal to minus b, this implies a value will be minus 1 by 4. So once we have these values, we will substitute back these a and b in the equation number hash. Let's call this as some important equation hash. Okay, therefore now therefore hash becomes hash becomes 1 by a square plus 1 into a square minus 3 is equal to a value is minus 1 by 4 by a square plus 1 plus b value is 1 by 4 a square minus 3. So minus 1 by 4 1 by a square plus 1 plus 1 by 4 1 by a square minus 3. So let's apply the Laplace inverse on both sides. This implies Laplace inverse of 1 by a square plus 1 into a square minus 3 is equal to minus 1 by 4 Laplace inverse of 1 by a square plus 1 plus 1 by 4 of Laplace inverse of 1 by a square minus this I can write it as minus square root of 3 whole square. So this is equal to minus 1 by 4. This value is sin t. This is sin t plus 1 by 4. This value is sin hyperbolic square root of 3. Here one more change, we need to write divided by square root of 3. Therefore Laplace inverse of 1 by a square plus 1 a square minus 3 will be equal to 1 by 4 root 3 sin hyperbolic square root of 3t plus minus 1 by 4 sin t. This is the required answer.